Good morning. I'm struggling with a scratchy voice here, but we're going to give this a go because I want to take a minute to talk about a few things to get you headed in the right direction for our quadratic modeling project. So, this video is going to focus on part one of that project. And you'll notice when you read over the project that we're going to need some numbers from your U of M ID. And specifically for two variables that we're going to use in our model. Variable B, we're going to use the first three digits of your UMID, and for variable V, we're going to use the last two. Now, I'm using a sample student for a UMID that I made up. The number is 543212234. And so you can see that I chose the first three digits for variable B and the last two digits for variable V. Then, as you move down the project and start to complete the items in part one, the first thing you have to do is make your model, your function h of t. And instead of writing the letter B or the letter V, you're going to use these two numbers. Now, you'll notice in blue font there, I recommend that you use Desmos to work on this project. You don't have to. You can actually do it by hand, but it's much more difficult. And we're trying to teach you to use the tools that you have available to, make math a little more accessible. So that's what I'm going to do. I'm going to show you how to run through Desmos and quickly answer these questions. It'll make this project so much faster. I do want to remind you, though, that you're going to be writing all these solutions out in your notebook. So as you're completing these on Desmos, be recording what you find in Desmos, including writing out your function and letting me know what your UMID was, things like that. Okay, so let's go over to Desmos. When you arrive there, you get the standard screen for starting new with a standard viewing window. And to accomplish what we need to accomplish, which is essentially, let me go back to the document real quick. Essentially, what we need is we need to get a graph of our function. We need to see some important features of our graph. Like we want to see the maximum point for this model, which would be the top of the parabola, the vertex. And we want to see where it crosses the x-axis because that will model where it hits the ground, right? So keep that in mind as we're running through this. All right, back to Desmos. So I'm going to start by just typing out my function the way it's written in the document. You can go ahead and enter h of t equals negative 16 t squared. That part doesn't change. Here's where we need to start using our U of M ID numbers. So I need to put plus 34t instead of plus vt, and I need to put plus 543 instead of plus b. All right, now I want to show you how we can make our model fit our real situation. When you are timing how long it takes for a t-shirt to be shot through the air, time starts counting at zero. There is no such thing as negative time in this scenario. So what I'm going to do is add a domain to my function. I just do that right here on the right-hand end. I start with a curly bracket, and then I'm just going to say 0 is less than or equal to t. And all that says is that the lowest time can go is 0. And then, of course, the t-shirt will eventually hit the ground and will stop, or it'll be caught, let's say, if we're shooting it into the crowd. But when I start this project, I don't know when that happens. So I just want to limit it to t is greater than 0. Okay, so now let's talk about some features of Desmos, because right now, I can't really see what's going on with this function. I see this sort of vertical red line, I guess, over on the right, but it's not giving me a true picture of the function. To fix that, what we're going to do is go over to this gear here. We've used that before when we've done Desmos, but go ahead and click the gear. And then I'm going to switch this to a blue line just because I like to see my functions printed in blue, but that's not really why I came here. So the reason I came here is this is a quick little trick so that it'll allow us to zoom in on the important features of the graph that we need. What we're going to do temporarily is we're going to create a table of values from our model. And to do that, all you have to do is click on the little table icon that says Create Table. All right, so when you do that, you get a table that looks something like this. Now, Desmos has defaulted to go from -2 to 2. We've already discussed how negative numbers for t don't make much sense. And then notice that the table has x and h of x, but the variable there is t. These numbers don't make much sense, so what I'm going to do is suggest that you just change them to fit your situation. So I'm going to start at 0, and I'm just going to change these x values, 0, 1, 2, 3, 4, 5, 6, 7, 8. And actually, I probably could have stopped at 7. Let's just go ahead and do that. Let's just take 8 out. Because as soon as I hit -3, I know that I've hit the ground, right? I've gone past the time when this sucker hit the ground. All right. It did not change the picture yet. I realize that. This is the trick here. Once you've set your table up and quickly change these x values to, or the t values to fit your situation, what we're basically saying is we're looking at 7 seconds of flight. Hit this zoom fit button, and all of a sudden everything shows in the display. And that's all we needed this table for. What I want to do now is I want to actually delete the table, because remember, in our document, in our assignment, we're trying to find out when it reaches its maximum height, how high does it go, and when does it hit the ground, okay? And those answers, decimals will show us. We just have to know where to look. So once I've got the picture the way I need it, I'm going to delete this table. Notice the graph stays, and now there's these little gray dots that show up on our function here when it's selected. Make sure that your function's selected. This dot right here, this shows us not only our maximum height of 561.03, but also the time that we achieve it. We achieve it 1.063 seconds into our flight. You want to know when you hit the ground? You go over here and click where it hits the x-axis, and it hits the ground. That's our 0 height at 6.984 seconds. And now, within a matter of seconds, no pun intended, you have most of the answers to part 1 of your assignment. And furthermore, you can use this picture to sketch a graph. Now, I do want you to draw it in your notebook when you turn it in, but you can use this as your template, right? You can see the x and y axis. You can see what numbers you need to label on there. And this is a really great way to quickly knock out part 1. If you have questions or you're not sure about what I did here, please feel free to ask. Questions are always welcome, and I'm happy to help. I want to give you enough hints so that you ace this thing. Okay, so that's my starter video for part 1. Hopefully you can hear my voice. If my voice clears up later in the week, I'll probably re-record this, but I wanted to get something out to you here early in the week for those of you that are starting. Good luck, and like I said, let me know if you have any questions.